Next, case 2, where the two population standard deviations are assumed to be equal. Our parameter of interest is still mu sub 1 minus mu sub 2, the difference between the two population means. In the previous example, we looked at a case when the variances were unequal. Now we have the case where the two variances or standard deviations are equal. So again, the same. And in this case, we want to look at the hypothesis testing and confidence interval. So parameter of interest is still mu sub 1 minus mu sub 2. And the point estimate is still x bar sub 1 minus x bar sub 2 from the two samples we take from the two populations. Now this time, we can compute what is called a pooled variance estimate when the two standard deviations or when the two variances are equal. Then we can pool the two sample variances as a weighted average of the degrees of freedom, and what we get is a pooled variance estimate S squared sub p. Now using S squared sub p, then we can compute the standard error of x bar sub 1 minus x bar sub 2 with this formula. So this is a more accurate estimate of the standard error if the two standard deviations are equal. So that's why if they are equal, or two variances or standard deviations, if they are equal, we need to use this formula for standard error, not the one that we used previously. Now, for us to apply the formulas, we need to make sure that the sample sizes are large enough so that approximating normal distribution will be valid. Then the confidence interval formula is the difference in the point estimates plus or minus the pooled estimate of the standard deviation times 1 over n sub 1 plus 1 over n sub 2 in square root. And the degrees of freedom now is a lot easier to compute n sub 1 plus n sub 2 minus 2. Now hypothesis testing, the same three types as before. Now the test statistic is going to be same as before, except that the standard error is now different in the denominator. And once you compute the test statistic, we can use the t dot dist functions for the p-value. And the degrees of freedom is very easy, n sub 1 plus n sub 2 minus 2. But we are going to use the Excel data analysis command to get this whole thing done.